Hi, I'm CDubs. I just recently graduated high school, and today we are going to be working on this AB integrals review. Though it isn't technically a BC review, BC covers all AB topics, so this is a good review for AB and BC. And if you're looking to do this alongside me or get the worksheets, they are in the description, so feel free to grab that before you start the video. And if you want to like and subscribe for more videos like this, please feel free to do so. All right, so let's just get right into the video. Okay. So here I am just rewriting the problem and making it easier so that when we actually do take the antiderivative, it'll just be easier. So I'm keeping everything, but then for the 4 over x squared, I changed it to 4 times x to the negative 2 so that the power rule is easier when we get there. And then now we're just doing the problem. We're doing power rule where we're adding 1 to the exponent and then dividing by the reciprocal. So like 3 plus 1 would be 4, and then you multiply times 1/4. And then same thing here with negative 6x squared. We're adding 1 to the exponent, and then we're multiplying by the reciprocal. So 2 plus 1 is 3, and then you do it times 1/3, so 6 times 1/3 is 2. And then here, 2 over x, we have the natural log rule. So anything over x, we change to the natural log of x, and that's what we have there. And then, again, we changed the setup there to make it easier so that we could do negative 2 plus 1 is negative 1, and then you would multiply by negative 1 over 1, and then that would be why you change it from plus to minus. And then here, every time it's just a number, you add the x on, and then don't forget to add your plus c. Okay, and then I think we're good on that problem. Or I think we'll just rewrite it to make it, again, easier and put it into the original format so that we don't have any negative exponents, just because it looks better that way. Nice. Okay, and then so the next problem. So this one is a little more difficult than the other. This one is split numerator because there's no equivalent for quotient rule when you're taking antiderivatives. So whenever we see a thing where there's x on top and bottom and we're able to split it up into 2 separate fractions, then that is what we want to do. And so that's what we're doing here. So we're going to split up the top and bottom so that we have, sorry, it's blurry right there. So focus, okay. So we split them. So x cubed over x and then minus the square root of x over x. That was me singing in the background, my bad. We changed the square root of x to the 1/2 so that it makes it easier to simplify, which is what we're doing right here. We're simplifying, but actually, sorry, let me go back. I just realized that that is wrong, what I wrote. The simplified version, because when you're doing fractions with exponents, you want to subtract the bottom from the top. So instead of doing 1 minus 1/2, because the bottom x is technically to the 1, right there I have minus x to the 1/2. It should be minus x to the negative 1/2 because it would be x to the 1/2 minus x to the 1, so x to the negative 1/2. And then that is why then we have 2x to the 1/2 because you are adding 1 to negative 1/2. So negative 1/2 plus 1 is then 1/2 instead of what it would have been if it were just 1/2. It would have been 3/2. But sorry for that mistake there. So that should be x to the negative 1/2. And again, don't forget your plus c's. Anyway, so here we go with the next question. So this is the first one where we'll actually have a numerical answer, just so you know for the future. So here we are going to be just taking the antiderivative, and for this one we're going to be doing kind of a U-sub, but an easier way of doing a U-sub, just kind of doing it in your head a little faster. So the reason there's a negative in front of the e to the negative x is the negative x, that is the exponent, is an inside function, so we need to do the reverse of chain rule. So since chain rule is when you are multiplying by the derivative, you want to be here instead of multiplying, dividing. That's how you do reverse chain rule. So since negative x is the inside function that you would be taking the derivative of, and the derivative of negative x would be -1, then instead of multiplying by -1, you would be dividing by -1, but again, since it's just 1, the negative just goes in front of the negative e to the negative x. And then for plus e times x, we're treating e like a number because it is just a number. So just like you would have plus 2, you would then take the antiderivative and make plus 2x. We're doing the same thing here and doing plus e times x. And then we are now multiplying by the parameters of the integral. And that's what we're doing here. So we are plugging in 1, so negative e times to the -1 is that, and then we're plugging in the 1 there, and then be careful of your parentheses. So whenever we're plugging in the first number, you just have there, but then when you're plugging in the second number, in this case that would be the 0, we're actually subtracting from the original number, so you need to make sure to put the parentheses there and to just be mindful of that so that you don't mess up the negatives or anything like that. So then you plug in the 0, anything to the 0 power is just 1, but then there's that negative, so -1 and then 0, and put them all together to get that. So there we go. And then we'll be moving on to the next question. All right, so this one is definitely a more difficult one. This is the first legit U-sub that we have on this worksheet, so it definitely is a little bit harder. So right here, you need to first choose a U, and my hand is in the way, but there we go. So you want to choose your U by kind of evaluating the whole integral. So here we have kind of two things that we're looking at. We're looking at an x squared, and then we're looking at the x cubed plus 2 to the third power. So here I chose x cubed plus 2 because once you take the derivative, and I'll show you that here, you get 3x squared. And if you see originally, we have the x squared right there. So basically, when you're choosing your u, you want to try to find something where the derivative will be in the original integral. So here we have x squared, and while the 3 is there, it's okay to have a random number in front of it as long as we have the variable to the same power or anything like that. So we wanted the x cubed because it gives us x squared, which we can then substitute in the original equation. So then we want to kind of isolate that x squared so that when we substitute it, it'll be easier. So that's what we're doing right here. We're isolating it. So then we have x squared dx equals du over 3. And then here, when you're doing your u-subs, you have to make sure that you remember to figure out how to change the parameters of the u-sub. So here we have 1 and 0. Those are our original parameters, but when you're doing a u-sub, you have to change them. And you do that by plugging the original numbers into your u. So right here, the u, you need to be taking your numbers, plugging them in, and then you'll get your new parameters. So you plug in 1, you get 1 cubed plus 2, which is 3. Sorry, that's down here. And then you have your 0, 0 plus 2, 2. So that's how you get that. And that will be what you're using for when you're changing your integral into the u form, using u as the variable instead of x. So right here, I'm just rewriting the original integral. And then here we have the u plugged in. So now this is the u-sub version. And I have the 1/3 there, just to clarify, this is from this. So anytime you have just a plain number without a variable, you can take it out and put it in front of the integral. So that's what I did here. So that was d over 3, but I took out the 1/3 and put it in front. And then we subbed in our numbers. So the 1 becomes a 3, that's here. The 0 becomes a 2, that's here. And then we plug in our u. So since this x cubed plus 2 was what we used as our u, then we're plugging that in right here. So now we have u cubed. And then the reason that the x squared is gone is because we plugged it in, right? So we had the x squared dx. So we plugged that in, x squared dx. We got rid of that and we put in du over 3 and we put the 1/3 here. So that is how you plug all of that in and substitute. And then now we have taken the antiderivative. You're doing the power rule. So where you would do 3, you add 1, it's u to the 4th now, and then you have to divide by 4. So it would be 1/4 times u to the 4th. But since we had that 1/3 in front, we then multiplied that 1/4 by 1/3 and then got 1/12. And then we have to, of course, plug in the numerical values and do all that algebra. Not very fun, but gotta do it. All right, 65/12, that's our final answer. So number 5, this one too is also a legit U-sub, although we are going to use a table this time to find the different derivatives. So again, we choose our u. Here we chose 3x, and we did that just so that we don't have to do any kind of chain rule or anything. So 3x, in any situation where you only have this original function, then choose the inside of it. So we have 3x, we then took the derivative is just 3. And then we substituted. Okay, actually I was for a second getting a little confused because what I wrote is wrong, so sorry, let me clarify. So the derivative of 3x is not 1/3, it is 3. So really we should have du over 3 equals dx. I got ahead of myself and then ended up writing it wrong. So what we should have had is du equals 3 times dx, and then we would have then isolated the dx to get du over 3. That's what we want, du over 3. So then we can then substitute the du in for the dx. So sorry about that, and I'll clarify when we get there for that section. But then again, we have to plug in our different numbers so that we can, get to the u version and use that for our final integral. So here again, I've rewritten the integral, and now we're going to change it into the u form. So again, just like in this other problem, I took out the 1/3. It just happened to be 1/3 both times. So here we have the du, and so if you're looking for the correct way, it is in the other one. But I had du over 3 in here, and then I took out the 1/3. So it should have been du over 3 here. So sorry about that again. And then, right, we plugged in our u. So we have u, we plugged it in here. And then this is the u version. We've plugged in our different numbers there. And then now we're just going to take the antiderivative, which is an easier one for this one, so that's good. And then doing the nice algebra, yay. So there we have it on that one. Yay, we've done the first sheet. Woo! Well, the front of the sheet. I had to use 2 sheets because my printer doesn't do double-sided. But yay! All right, so next sheet. Okay, so number 6. This one, we are again going to do a kind of U-sub in our head kind of thing. Sorry, for a second I got scared that it wasn't recording and that I was gonna have to redo everything, but it is recording, so yeah. Okay, so here we are going to be just, this is the logarithm rule, so since there's only one x in the bottom, we then take that fraction, which is basically, we're keeping the 5 in front, and then we do the natural log of 4x plus 1, And then here we have divided by 4 because we have done the reverse chain rule kind of like in our head. And so basically, since we have a 4 in front of the x, that would be a chain rule. Since we're doing reverse, instead of multiplying like we would with chain rule, we're actually dividing. So we're dividing by 4 in the front to do that reverse chain rule. And then, of course, plus c. And then here, if you wanted to check yourself, a good way to check yourself is always just take the derivative of the antiderivative that you have now. So if we just want to practice that, so if we did take the derivative of this, the plus c would go away because it's just a number, and that would be 0. And then we have 5/4, then you would multiply by 1 over 4x plus 1. But then, again, because the 4x is there, you would then multiply the whole thing by 4, and then the 4's would cancel, and you would have 5 over 4x plus 1. So you can always go back and check your work. All right, this next one. This next one is a pretty tricky one. This is an absolute value problem, so we are going to have to split up the function, well, not function, the integrals, and do 2 separate integrals because we'll have a positive side and a negative side. Sorry, my brother's eating cereal and being kind of loud, but that's okay. So first, we basically need to find the split point. So that is what we're going to do right here. And this is just in parentheses because you can do this in your head. So we're taking that 2x minus 2, set it equal to 0, solve for x equals 1. So now we have our split point where we can create a negative side of the integral and a positive side of the integral. So right here, we're doing the positive side. So we know that the 0 to 1 is the positive side, negative side, because if we plug in a number between 0 and 1, the function will come out negative. So if we plug in 1/2 for x, 2 times 1/2 is 1, 1 minus 2 is -1, so that's negative, and that would come out for any number in between 0 and 1. So this is the negative side, and we put a negative in front of it. And then the positive side, 3 to 1. And same deal goes with that one. If you plug in a number, it's going to be positive. So if I plug in 2, 2 times 2 is 4, 4 minus 2 is 2, that's positive. So that is the positive side. And then here we are. We're doing the algebra again. Gotta, plug in the numbers, the parameters. Sorry, that's 3 and 0 if you can't see that. I think it's a little off the screen. So then we have, you plug in your 1, 1 minus 2, -1. Again, be careful with your parentheses and your negatives because right here, there's a negative in front, but always remember that when you're doing the second number, we're subtracting it, so negative times a negative is positive. And then we have this other one as well. Oh, whoops. And then we have 5. There you go. All right, number 8. So this is an FTC problem. That is the fundamental theorem of calculus. And so we'll get in there and notice that we have our givens. So we have x is 1, y is 3, but that doesn't matter. So f of 1 equals 3. So we want f of 0, right? That was something that it was asked in the problem. If you can't see it because my hand is covering it, sorry about that. So the setup for FTC problems where we have this is the number that we want, and then this is our given. So we will have the number that we want here, and then we put that here as well. So f of 0, and then we have 0 as our x. And then here, this is our given. So it would be f of 0 equals f of 1, but here we're just putting 3 because we are given it. So then the 1 goes here because it's f of 1 equals 3. So that's the setup. And then you have our function here. So then we're just going to simplify it. Again, anytime you see a square root, it will make the problem a lot easier if you simplify it and make it to the 1/2 or 3/2, whatever it is, because it makes it easier to do power rule. where we add 1 to the exponent, so 1/2 plus 1, 3/2, and then we multiply by the reciprocal, so 2/3, and then power rule again here. And then we're just plugging in and doing the algebra, not arithmetic, adding, subtracting, sorry. And there we go, 1/3. And just to, here, let me go back a little bit to clarify. So in problem 7, actually, sorry, no, 8. So now we're going on to question 9, sorry about that. So in question 8, the way we did it was that we used our given to get our final number because we have a given. And so we don't have a plus c here because we have our given. But in this next problem that we're going to do in number 9, instead of using our given to find a number, we're going to use the given to find our c. And then from there we can find a function. So instead of plugging in on the front end like we did here, we're gonna plug in on the back end. So here we want to find f of x. So that's a function, not a number. And that's why we're doing it this different way, where we're not going to use the given at the beginning. We're going to use it at the end because we don't have a number right here. So here we are writing in the function. And then here, taking the antiderivative. So here, remember that the antiderivative of sine is negative cosine. So when you have a negative sign, you will get positive cosine here. And we had a -2, or, well, we'll just go with 2 because we got rid of the negative. And we then divided by 4 because we're doing the reverse chain rule. So again, instead of multiplying like chain rule, we want to do the opposite. We want to divide. So we divided by the 4x, which we would normally do chain rule with. And then power rule. Don't forget your c's. So that would be kind of a U-sub in our head because reverse chain rule is U-subbing. But we're just gonna do it in our head. It's easier. And then here we are. This is how we're going to find our c. So we're using our given here. We're doing 3 equals f of 0. And then we're using the function that we just got, where we changed 2/4 to 1/2. And we're plugging in. So we did f of 0 equals the 1/2 cosine times 4x, not times, but cosine of 4x plus x squared. And then we're doing our plus c. And then we're using 3. So 3 equals 1/2 times 1 because the cosine of 0 is 1. And then 0 squared is 0 plus c. And then here we get c equals 5/2. So there you go. So in these types of problems, you'll have to use your given, plugging in the 0 into the f of x, because this is what we have for f of x, and solving, equating, I guess, the equation 2, 3. And then here we are. Here's our final one. All you have to do is copy the original, or not the original, but the function that you got, and then just plug in for c what you just got. All right. Wow, we've done a lot so far. We're doing good. All right. And then, so number 10. So number 10 is more of an MC problem for an AP exam, if that's why you're here, if you're studying for an AP exam. So that would be the type of problem that this is. So here we're given 2 different integrals. Oh, and now my hand is covering it. I'm so sorry. But we're given 2 different integrals. And so this is a U-sub problem. But first you need to figure out which integral you're going to be U-subbing. And just the way you're doing that, figuring out which one, is you want to choose the one that's more U-subbable, which is a weird word. But in this problem, the one that's more U-subbable is the first one, because we have a 2x inside of it, and the 2x is something that we can make our u, and then we can go about with that. But see, if we chose the second one you can't really do u-sub because it's just one function. There's nothing to make a u because it would be the same thing. like if I plugged in u for f of x, then it would be the same exact integral, just with the u instead of an f of x. But here, a u is different than 2x. So we want to choose the one that we can actually do a u sub with. So we have our u, 2x, and then we took the derivative, 2, and then again, we're isolating the dx. That's always what we want to do. We want to isolate. So we have du over 2. And then again, we always want to make sure that we change our parameters based on the u that we have. So we plug in the 4, we get 8, we plug in the 2, and we get 4. And see, now we have 4 and 8, and we already know that we're heading in the right direction because those are the same parameters of this then one, which is our goal. We want the original function here to match this one. So since we have 4 and 8, we're doing good. So then we're starting with 6. We're saying 6 is equal to the original function. We're just rewriting it. And then we're saying that is equal to, now this is our u subbed form. So again, we did this. We have the du over 2. We're putting the 1/2 in front just so that we can have the numbers on front and the function inside. We have the du, and then we have our f of u here. And then we have 8 and 4. And now you can kind of see, if you get rid of this 1/2, that this integral is the same as this one, but with a different variable, which is exactly what we want. That is very good. We're good sign. And then here, since we don't want any number in front of it, we isolate this. So we had 1/2, and we had this whole equation was equal to 6. So the way that we're isolating that, since we have 1/2, this integral equals 6, we multiply by 2 to get rid of the 1/2, and then we have this function is equal to 12. So there we are. Again, just accenting that they are the same integral, and that is our goal in problems like this. Excuse me. Yep. In MC problems, they'll have a lot of different integrals that kind of look the same, and you'll have to choose the right one. Okay, so 11, another nice u sub. Well, maybe not nice, but it's a u sub. Again, we're going to find our u. We've got our u as f of x this time, and again, we want to find, we want to choose our u by looking for something that is the derivative of the u that we chose. So in this one, we chose f of x because we see here that, oh yeah, right there. There's our f prime of x, the derivative. We know that this is the derivative of this, so this is a good choice for u. And then we take in the derivative, and then again, we just want to have the u version of the x parameters. So we're changing the parameters. F of 1, 6, f of 3, 8. There we go. And then again, we like to rewrite the integral. So here we've changed the parameters. We're putting in our u. Oh, and then let me move this real quick. Oh, so you can see it. There we go. Oh, sorry about that. So antiderivative of g prime of u is g of u. We're using the numbers, plugging them in. G of 8, 1, g of 6, 4, 1 minus 4, negative 3. There you go. And then we're done. We did the whole worksheet. So good job. Sorry, my desktop is showing. I apologize for this. There we go. But yes, yay. Good job. We have a lot more videos like this on this channel. So if you're looking for any kind of, oh, this is my dog, sorry. If you're looking for any kind of other calculus help, there are tons of videos on this channel for that, of different girls teaching different topics. So go look for that. Feel free to like and subscribe and come back again. Thank you.